Hi, for today's video, let's revise on the reaction from the chapters of acids, bases and salts and also some mole calculation. So I've chosen a question from O-Level Science Chemistry 2016 Paper 3 Question 5. Let's first have a look at the question. Acid J has a relative molecular mass of 98. A 200 cm3 aqueous sample contains 196 grams of J. So for part 1, calculate the concentration of J in gram per dm cube. Alright, so for part A1, let's recall on the formula of concentration in grams per dm cube. Alright, that will be the mass over the volume in dm cube. So we have gotten the mass as 196 grams. And we have the volume given as 200 cm3. Then here we need to do a recap that 1 dm cube is equals to 1000 cm3. So if we need dm cube, when we divide, that will be 0.2 dm cube. Okay, so when we divide, we'll get 980 grams per dm cube as the concentration. Alright, so for part B, calculate the concentration of J in moles per dm cube. Alright, so this is another calculation question. We have concentration in moles per dm cube. Okay, so if you realize what's the difference in gram per dm cube and mole per dm cube, it's just the numerator part. So we have to recall on another formula whereby mole is equals to mass over molar mass, and this is in grams. So if you see that this is actually the gram, right, it's the mass, we'll just take this concentration divide by mR, that will give us the mole. Alright, so we have concentration in gram per dm cube divided by relative molecular mass, that will be this moles per dm cube. We have got 980 divided by, and it's given that the molecular mass is 98. Alright. So when we divide this, we'll get 10 mole per dm cube as our answer. Alright, so this is for our A part 1 and part 2. Let's look at part B. When J is mixed with acidified aqueous barium nitrate, a white precipitate K forms. Okay, so part 1, barium carbonate is white and insoluble in water. State why K cannot be barium carbonate. Okay, so this be part 1. Okay, so they are saying that the white precipitate could be barium carbonate. But remember that previously we have actually got the acidified aqueous barium nitrate. So if K is barium carbonate, alright, it would have reacted with the acid. Alright, it would have reacted with the acid. So recall from the chapter from acids, bases and salt. Acid can react with carbonate to give us salt, carbon dioxide and water. So then the precipitate will no longer be there. Alright, so let's look at part 2. Suggest the identity of K. So for part 2, since K is a white precipitate, for barium, we only learn 2 insoluble salts of barium, which is barium carbonate, and the other one is just barium sulfate. Okay, recall that all sulfates are insoluble except for barium, lead, and calcium. Alright, so this must be K is barium sulfate. Alright, Okay, next, part 3. Write a balanced chemical equation including state symbol for the reaction of J with aqueous barium nitrate. Alright, so J, since K is barium sulfate, the sulfate must have came from J, right? And they mentioned that J is actually an acid. So an acid with sulfate ion, that will be sulfuric acid. So this is part 3, right? So let's first write this down. We have sulfuric acid plus is added with barium nitrate. So we have barium nitrate. Barium carries a 2 plus charge. So nitrate carries a minus charge. Therefore, our nitrate has got to have the 2. Okay, for those who are not too familiar, so we have barium 2 plus, nitrate minus. So when we cross, we'll have 1 barium is needed, but 2 ions of nitrate. Alright, so this is how we balance the compound, and this is gonna give us our K, barium sulfate, which is BaSO4. So let me do this example also. Barium 2 plus, sulfate is SO4 2 minus. When we cross it, 1:1, therefore it's just BaSO4. Alright, so this is gonna give us barium sulfate, and what do we have left? We've got the hydrogen ion and the nitrate ion, so this is gonna form the nitric acid. Alright, so now we have to balance the equation first. We've got 2 nitrate first of all, and 2 hydrogen, 1 barium, 1 sulfate ion, and so this is balanced, but they require the state symbol, so let's fill that in. Sulfuric acid is aqueous. Barium nitrate, all nitrate salts are soluble, so this is aqueous as well. Barium sulfate is the insoluble salt, so it's solid, and we have nitric acid as the remaining aqueous. Okay, so this is the solution for part 3. Then this will be the answer for the whole question.